Welcome to Maths with Kaini. We are going to solve another question from past year paper, IGCSE Add Maths. This is the last question of this paper. Question number 12 is the last question of the paper 0606 to May-June 2019. This question is about function and composite of the functions. So let's see what the question is asking. Part A consists of 3 parts, then 2 parts I can do it now, then the next I will do it after a while. Therefore now the functions of G, f and g are defined by this. Therefore these 2 functions are defined. Therefore the domain of f has been given to us is x is more than 0. Domain of g has been given to us, x is more than 0. Now he's asking to find the range of the function g. The range of the function g, range means the values of the y. When x is more than 0, therefore this number is always more than 0. Therefore if number is more than 0, if you are adding this number to negative 9, therefore always the range will be more than negative 9. Therefore range of this function, range of g is y more than negative 9. Range of g is always more than negative 1 because it is a positive number. Adding to this, therefore the value will be always more than negative 9. So this part we have done. Now he's asking us to find the domain of g of f of x. The domain of g of f of x is actually what you want to do. You want to put f of x inside g. Therefore this f of x has to go inside the function g. If this f of x goes to inside the g of x, but this value should be more than 0 because only positive numbers can go inside g by the definition of the domain. But since you are going to put this value inside this value should be more than 0. Therefore 5x minus 2 should be more than 0. Therefore 5x should be more than 2. Therefore x should be more than 2 over 5, which is 0.4. Therefore all the values which you can put inside this function should be more than 0.4 so that this is a positive number so that you can put it here. Okay, therefore this is the second part of the question. Therefore domain of, if you want to write, domain of g of f of x is defined by x more than 0.4. This is the domain of this function. Okay, now we are going to do the third part of this question. Okay, now he's asking, showing all your working, find the exact solutions of this equation. Now, let's see what is this equation. Now, it says that f of x, we have to substitute in g of x. Therefore, now we are having, we know that g of x is equal to 4x squared minus 9. Now, g of f of x, therefore, will be 4 times f of x. F of x is 5x minus 2 squared. Therefore, this is, you see, just this replaced by this minus 9. This should be equal to 4. Therefore, this should put it equal to 4. Now, to solve this equation, no need to expand, just take this that sign. Therefore, you are getting 4 times 5x minus 2 is equal to 9 plus 4, which is 13. Now divide this by 4. Therefore, you are getting 5x minus 2 squared is equal to 13. This is sum of these two. Divide by 4. Divide by 4. Now take the square root. You are getting 5x minus 2. When taking a square root, you should remember it is plus or minus. Plus or minus the square root of 13 divided by 4. We know that 4 has got a square root 2. Therefore, you can write it. This is 5x. So 2 also I can write that side. 2 plus or minus the square root of 13 divided by 2. Then I can divide by 5. Then if I divide by 5, I'm going to get x 2 over 5 plus or minus the square root of 13 divided by 10. Divided by 5, therefore this will be 10. Anyhow, you can see that you have got two answers for this equation. But 2 over 5 is actually 0.4. Therefore, this is 0.4 plus or minus the square root of 13 divided by 10. If you remember, in the second part, we said that x should be more than this value. Therefore, this minus this is not valid actually. But anyhow, the solutions are these, but 0.4 minus 13 over 10 is not valid. Okay. Now we can go for the B part of this question. This question, question 12, the part B. They have given a function h to us defined by this, and the domain has been defined this. Therefore, h of x equal to x squared minus 1, x is less than negative 1. Now he's asking us, so what is state the geometrical relationship between the graphs of h, x, and h inverse of x. We know that h inverse is actually means we are changing x to y, y to x. Therefore, the graph of any function with its inverse is symmetric about the line y equal to x. Therefore, whenever you are having any function same as h of x and h inverse of x, the inverse of that, the graph is symmetric about line y equal to x, because you are replacing x by y and y by x. So they will be symmetric about the line y equal to x. Now, second part of this, it says that find an expression for h inverse. Now let's see how we can do that. We know that y is equal to a square root of x squared minus 1 for the values of x less than or equal to negative 1. Always I'm advising my students, first you change y to x and x to y. Don't forget here also. That means in this relationship, your x is equal to the square root of y squared minus 1, and y should be less than or equal to negative 1. Okay? Now, try to make y as a subject. If you are going to make y as a subject, first you have to remove this square root. Therefore, you are squaring both sides. You are going to get x squared is equal to y squared minus 1. Now, y, you can bring x squared, negative 1 this side. Therefore, you can say that x squared plus 1 is equal to y squared. Now, to get y, you need to square root both sides. You know that when you are square rooting, you have to use plus or minus. Therefore, y is equal to plus or minus square root of x squared plus 1. But one of them is your function, not both of them. One of them is wrong. So look at here. You are saying y should be less than negative 1. Therefore, if y is less than negative 1, y cannot be equal to positive this. Therefore, y is equal to negative square root of x squared plus 1. Therefore, h inverse of x is equal to negative x squared plus 1. So, this is your h inverse. It is very important to look at this to find which sign is accepted. Thank you for watching. This was the last question for this paper 0606, variant 22, May-June 2019. Thank you.